this video, we're going to look at how to use the mean value theorem. And as you can see, I've already written it to the side. So it starts off very similar to Rolle's theorem. Given f on a closed interval, we need f to be continuous on the closed and differentiable on the open. Okay. Where it changes is that we don't have to check that the endpoints are equal. Okay, so that check of the endpoints equaling each other is only for Rolle's theorem. We don't need it for the mean value theorem. However, the conclusion is a lot different. It says there is C in A, B such that f prime of C equals. All right, so what this basically is that if you have a curve, so let me go ahead and just make up a curve on a closed interval, okay? What we're saying is that if you drew this line segment and calculated this slope, so this slope would be f of b minus f of a all over b minus a, then there are values, at least one spot on this curve that has the same slope. So for example, that guy looks like it's got the same slope. And maybe right there, it looks like it's got the same slope. And maybe right around there, it's got the same slope. So for this example that I drew, there's actually 3 values of C that would match it. Okay, but it's only guaranteeing that there's at least one. There's at least one that lives in here that will happen with. Okay. A couple of problems in the homework have some examples at the beginning that kind of do this where you eyeball it. We're going to actually find it ourselves exactly. All right, so let's go ahead and look at a function. We're going to do the following. So when we do the mean value theorem, what you want to do is you want to check for continuous and differentiable. Continuous on the closed, differentiable on the open. Okay. Then you're going to find f of b minus f of a all over b minus a. You're going to find this number. You're going to find the derivative. And then you're going to set these equal to each other and solve. All right. So let's go ahead and try a problem. All right, so here's our mean value theorem example. So I've got this polynomial on a closed interval. So before I can use the mean value theorem, I've got to make sure that f is continuous. So yes, f is continuous on our interval because it is a polynomial, and it's also differentiable. I'm saying that a polynomial is a nice smooth curve. It doesn't have any sharp pointy parts, any gaps, any problem spots. So it's good and good to go. Okay, now the mean value theorem, we are going to calculate f of b minus f of a all over b minus a. So I want to know what's f of 3 minus f of negative 1 all over 3 minus negative 1. Okay, so let's see what we get. F of 3. 3 cubed is 27 times 2 is 54, plus 9 is 43 minus 1, I believe, is 42, or I went the wrong way. 54 plus 8 is really what I'm interested in. Is this math painful? Okay, hold on. Let me pause it while I number crunch. So I want to know what f of 3, what f of negative 1, and then what this value is. All right, so I did some number crunching. F of 3 is 62. F of negative 1 is negative 6. And then I do have some negatives happening. So 3 subtracting a negative 1 is 3 plus 1. So let's see, the top is 68. The bottom is 4, and I get 17. Okay, I got 17. Woohoo! What do I do now? Okay, well, we also need f prime of x. So let's go back up to the original function. F prime of x would be, let's do power rule, 6x squared plus 3. Is that sounding good to you guys? I think so. So here it is, 6x squared plus 3. All right, now here we go. We're going to set these two guys equal to each other. That's what the mean value theorem says, is that there's some spot where the derivative equals this slope of the endpoints. Okay, so if I go ahead and set these equal to each other, I get 6x squared plus 3 equals 17. What is that? 6x squared equals 14. X squared equals the very lovely 14/6, which is the same thing as 7/3. So So x is going to be, oh my gosh, plus or minus the square root of 7/3. That is funky. Okay, now the question is, I only needed one of these. Do both live in -1/3? All right, well, let's see. Do both live in -1/3? That's a good question. Let me check. With the aid of the calculator, I found out that the plus and minus square root of 7/3 is a positive 1.7 and a negative 1.57. Now remember, our original interval was from -1 to 3. So are both of these in there, or is just one? Just one. So in this case, we got two solutions, but only one is our C, according to this theorem, because that's the only one that lives between -1 and 3. So C, according to the mean value theorem, is the positive square root of 7/3. All right. That one was a little messy, but hopefully it's going to get the job done. So that is how we use the mean value theorem. You got to make sure it's continuous, differentiable, find f of b minus f of a over b minus a, find the derivative, set them equal, and solve. Only keep the answers which are in our interval. All right, good luck.